Welcome back. Unit 8, Lesson 2 is on electric currents. If the effects of electricity were limited to static attraction and repulsion, then electricity would be about as useful as refrigerator magnets. But you know that we use electricity to run appliances, start cars, and keep our clocks operating. Electricity powers everything from lights to trains because it can send power through wires, often over great distances. Let's take a closer look at how electricity moves. You know that static electricity is composed of charges from an excess or shortage of electrons. These static charges can be built up by rubbing different materials together so that the electrons move from one substance to another. Electric current occurs when there is a flow or movement of negatively charged electrons. A quick discharge of static electricity is an example of such a current. This is how lightning forms, or the shock you get from a doorknob. But the appliances don't run on quick static discharges. Usable electricity comes from continuous current. To control and direct the continuous current, we use conductors, insulators, and resistors. And remember, electricity flows like a river. If you take apart a wire, you will find the inside is made of one or more strands of metal, usually copper or aluminum. In metals like these, many of the electrons are free to move throughout the metal. This allows them to carry an electric current. Materials like these are called conductors. They are used to carry electricity from place to place. Think of the conductors as a tube and electricity as water flowing inside it. Any material through which electricity can flow is a conductor. A copper wire is a good conductor of electric current charge as it flows through the circuit. Gold is also an excellent conductor, though very expensive. Silver, the more plentiful metal than gold, also conducts electricity. The outside of a wire is usually covered with plastic, although you might find fabric-wrapped wires in an old house. In some materials, atoms hold on to their electrons. If electrons are not free to move, it becomes difficult for the electric current to flow. These materials are called insulators, and they are used to stop the movement of electrons. A substance that cannot conduct electricity very well is considered an insulator. The rubber casing around a speaker wire serves as an insulator for the electrical current. You can think of insulators stopping the flow of electricity just as a dam stops the flow of water. Glass, porcelain, rubber, and many plastics are insulators. But do not assume all non-metal materials will act as insulators. Water, wax, and many substances may surprise you by conducting an electric current. A diamond is an insulator. This computer chip uses resistance to control electron flows. And these colored objects, they are insulators that you may see on power lines. Test your knowledge of conductors and insulators with this on-screen activity. What you would be required to do here is decide which of these is an insulator. Is it copper? Is it glass? Is it gold? Is it a diamond? Or is it silver? You could stop this recording, open your OLS, and try to complete this. It would be very good, hint, hint, because this will be on your unit assessment. I am just going to help you with one by showing you that copper is a good conductor. It's your job to do the rest in your OLS. There are no ideal conductors or insulators. Even the best conductors can slow down an electric current. Insulators can be overwhelmed by so much electricity that the electricity will begin to flow. In addition to conductors and insulators, there are substances that allow some movement of electrons. As the electrons are slowed down, some of their energy is converted to heat. Thermal energy. Remember that? We learned about it last unit. We call this slowing of electrical current electrical resistance. The photos on screen show common household appliances that use resistance. They convert some electricity to heat. By making the resistance here, it causes the coils to heat up on a stove, or inside a toaster, or in a space heater on those chilly nights. These are fuses. You can think of resistance as an obstruction that slows electric current the way that tight netting or a narrow tube would slow down the flow of water. In a previous lesson, you learned that rubbing different materials together moves electrons and builds up static charge. The force that drives an electric current can come from many sources. Chemical reactions in a battery, light falling from a photovoltaic cell, moving magnetic and electrical fields in a generator, or even stored up static charge in a device called a capacitor, can all drive electric currents. Because electrons repel one another and are attracted to objects with positive charge, they will flow from the negative to the positive. It's possible for the flow of electric current to lead to a dead end, building and releasing static charges, or charging and discharging a battery can lead to filled capacity or use up available electrons. Electric currents that provide a continuous push to keep the electrons flowing are useful. That's what powers the appliances in your home. As you know, electricity flows in a current and can be used to do work, such as lighting a light bulb. In the next lesson, you will learn how engineers direct the flow of electricity to take advantage of its many uses. Take a look around you. Name at least 5 things around you that are powered by electric currents. Did you know that you can get electric power from a liquid? Many liquids are good conductors of electricity. In this activity, you will see how much electric energy you can squeeze out of a lemon. Once you have completed this recording and maybe taken a minute to try that activity of making a lemon, you can go ahead and complete your lesson review. This is a very important part of your lesson. Filling out this chart will help you not only prepare for this assessment, but for the end of the unit test. So make sure you know, is copper wire a conductor, a resistor, or an insulator? Please complete this assignment in your student pages and then take the assessment that is located on the next page.